Hello and welcome back to Higher Maths Integration. We are looking at integrating trigonometric functions, in particular sine of ax plus b and cosine of ax plus b. So we looked at differentiating these functions in the differentiation chapter. So it follows that the integral of the cosine of ax plus b is 1 over a sine of ax plus b plus our constant of integration, as always. And the integral of sine of ax plus b dx is negative 1 over a cosine of ax plus b plus our constant of integration again. Okay, so we're just going to do a few questions that uses that. So they are given in the exam. So find the integral of sine of 4x plus 1. So here we are up here. So a is 4, b is 1 basically. So that would be negative 1 over 4, negative 1 quarter, cosine of 4x plus 1 plus the constant of integration. That's it done. That's all we're doing. Now remember, if we are asked to evaluate that, when we are integrating or differentiating, we must use radians. That is why we do radians in the higher course, because when we're integrating and differentiating, it won't work with degrees. So we must use radians. I say it won't work with degrees. It can. We can kind of manipulate it, but it's a very tricky thing to do. So we just use radians basically. Question number 2. Find the integral of cosine 3 over 2x plus pi by 5 dx. Remember, pi over 5 is just a number term, guys. There's no x's involved in that. So it'll be 1 over 3 over 2 sine of bracket plus c. So if we're dividing by 3 over 2, we're just multiplying by 2/3. So 2/3 sine of bracket plus c. So notice in question 1 and question 2, the bracket remains exactly the same as what it was in the question. That occurs 100% of the time when doing these questions. Okay. Question number 3, find the integral of 2 cosine 1/2 x minus 3 dx. So again, we're just doing the same thing. We're going to use our rule up here. Okay. So that'll be 1 over 1/2 multiplied by 2 sine of bracket plus c. So 1 over 1/2 is just 2 over 1. So 2 2's are 4. So 4 sine bracket plus c. Question number 4, so the integral of 5 cos 2x plus sine of x minus root 3 dx. So again, we're just using the rules above. It's 2 separate terms here to integrate. Just integrate through using the same rules as above. Remember, root 3 is just a number, so that won't have any impact on the value of a for the second term here. And last question, differentiate 1 over cos x with respect to x. We're differentiating again. And then hence find the integral of tan x over cos x. So we need to bring all of cos x up. So cos x to the minus 1, power to the front, reduce the power by 1, multiply by the derivative of that bracket, which will be negative sine x. So we've got negative 1 times negative sine x here. So that'll be sine x multiplied by bracket to the negative 2. So that'll be sine x over cos squared x. Okay, so when this cos x term comes up, we need to write that as bracket to the power negative 1. Just like we're doing in the differentiation chapter. Hence, find the integral of tan x over cos x. Well, I don't have a tan. But if we remember from National 5, tan x is sine x over cos x. Okay, which is what I've got. So rewriting tan as sine over cos, we've actually got the integral of tan x over cos x is the same as the integral of sine x over cos squared x dx. Now, that is my answer to part A. How did I get it? I differentiated 1 over cos x. So if I integrate this, I will get back to 1 over cos x. So the integral of tan x over cos x dx is 1 over cos x plus c. Now again, just like I'm doing the chain rule questions, we could not be asked this on its own. It's beyond the scope of the course. But we do know that integration undoes differentiation, so we could be asked this as a part B, where we're just being basically asked to undo what we've done in part A there.